This is a right angle, and this is a ribbed right angle. By the end of this video, I'm going to show you how to model, mesh, and set up the simulation in order to solve them for stress, strain, and deformation for both of these right angles. At the end of the video, I will also reveal a special feature as to why these ribs are actually used. I'm going to select the units as millimeter, and in the XY plane, I'm going to draw the rectangle which is going to be fixed support. These angles are usually used in case of shelves or racks, and hence one face is always attached. The horizontal length is going to be at 15 millimeters, and the vertical height will be 80 millimeters. I'm going to extrude this for 10 millimeters. Make sure that the operation is at add material. The direction is going to be normal and outwards, and click generate. In order to create the second face or the right angle, I am going to reselect the XY plane and draw a rectangle on the face itself. The thickness of both the plates is going to be 10 millimeters. This is going to be 10 millimeters. Extrude it for 80 millimeter length and click generate. As both the operations were at add material, both the extrudes are fused to form a single body, which can also be seen in the left hand side in parts and bodies, which is showing only one. In order to apply the load, I am going to face split the upper face. To do this, I have selected both the edges and created a split edge. Select the face split tool and generate. This has created two different faces. Within the setup, we first need to mesh this body. I'm going to give a coarse mesh, say of 10 millimeters, just to see how it is meshing. It's a coarse mesh, and we need accurate answers are dependent on the fineness of the mesh. This is quite a fine mesh. I'm going to give the fixed support to the back face, which is going to be attached to any wall or any surface. I'm going to give a downward acting force on this split face. Let the force value be 100 newtons, which is equivalent to almost 10 kgs of weight. Now this is showing an upward direction. We need it downward, so change the direction. I'm interested in deformation, the strain, and the stress. This completes our setup. Now just click on solution and click solve. The solution is completed, and we can see that the deformation has occurred. The deformation causes the overhang to bend downwards. In the strain, we can see that the strain is mostly concentrated on the upper and lower surfaces. This is due to the fact that the upper surface undergoes extension and the lower one undergoes compression. More strain is concentrated at the point of the right angle. Stress and strain are usually the same, and hence where there is strain, there will be higher stress. The deformation I can see of 0.05 millimeters in the downward direction. Now let us move on to the ribbed. In the ribbed case, I am going to create a rib for the support. Draw the rectangular rib profile. I am drawing it slightly inside the existing profile, as when I extrude it, it will merge with the existing one and form a single body. Extrude it for the thickness of 15 millimeters. And we can see that it has formed a single body by merging with the existing right angle. I have measured it just like the previous one at 0.5 millimeters. The boundary conditions are going to be the same, as the back face is going to be fixed support and a downward acting force on this split face of 100 newtons. Change the direction again to downwards. Deformation, strain and stress, and solve. From the deformation, we can see that the deformation has decreased from 0.05 millimeters for a simple angle to a 0.01 in the ripped case. From the strain, I can also see that the strain has now reduced as well, and it is no longer concentrated on the right angle. It is concentrated. The highest peak is seen on the angle face, where the angle changes. And this is the priority, or this is the feature of ribs. Right angles tend to concentrate stress and strain where they are present, and hence they are avoided, and hence fillets and chamfers are given anywhere where they are necessary. Only the overhang deformation is seen. And for more such videos, please subscribe.